Hi all, Mads Barnkob from Kaizer Power Electronics here. This video is going to be about building a soft start and safety controller box, which goes along with the Tesla Coil show controller project. Now, long ago I did build a soft start box, so let's just take a look at that. As you can see, that utilizes some different plugs for 16 and 32 amps, and on the inside it is just a bunch of relays and timers and some power resistors. Now I want to upgrade this to actually also have some safety features like the emergency stop that I built into the show controller in part 7. And that's the circuit we have sitting over here. This yellow safety relay, we want that to be part of an actuating sequence to the main contactors. So let's take a look at the schematics and let's build this box. Okay, the overall plan for this box is to have a input switch which can switch between a 16 amp and 32 amp CEE plug input. I will use a bypass switch from one of my UPS teardowns for this. After that we have the first contactor, and then we have the slow startup or slow charging startup relay, which just has 3 power resistors sitting across it. So once this is not actuated or open, the current will go through the resistors, limiting the inrush current to whatever load I have over here on the outputs. To control this, I'm using a 24 volt DC power supply, a Siemens Series 3TK2822 safety relay, a Omron H3DE M1 timer, and then a key switch with a normally open, normally closed. I have a normally open reset button and a red LED and perhaps a blue LED. I'm not quite sure about these colors on the LEDs yet. So the way this works is, as I have the key switch put into the safety reset, I would not be able to reset the safety relay if the key switch was turned on. Now the key switch will turn on the timer, and it will also power the first contactor. So while the timer is also powered through the relay from the safety relay, the signal to start the timer does not really work, as the whole timer circuit has no power. So I need to reset my safety relay first, and first then it will have an effect to turn on the key switch, and then the red light will turn off once it's, let's say, dangerous. And this is quite important safety-wise, as you can never trust having a lamp signaling some kind of status, because what if the lamp is broken? Well, it might signal red if it's dangerous, but if the lamp is broken, you have no idea. So off means dangerous. So if it's turned off, you have to check your cables. If it's actually powered up, it will also be off, and you have to be cautious. Once these are powered up, you will know that they're in a safe state if they are lighting up. So yeah, that's the plan. Let's build it. Alright, we are in the workshop. We got our plan. We have our safety relay, we have our bypass switch, we have some additional reset button with blue light. We have the parts from the old box, like power supply, timers, relays, some more lamps and key switches, which is sitting up here. And then, of course, we need a better enclosure. Now, this was built into an old UPS, but it's kind of a thin-walled metal plate. Did not quite live up to my expectations when pulling out large CEE plugs like a 32 amp service plug is. So I have some other bugs here. Now this is a good old sturdy iron frame with vents, nice big handles. This did house I think it was a welding transformer or isolation transformer for something like welding. So I only have the plate for the top, and I'm missing 2 plates for the sides. So here I have some aluminum plates from base station amplifiers. That's some good 2mm aluminum plate. Just needs to be cut up in order to fit the sides here. So I just need to make a single cut and another one here. And I got 2 of those. First, let's disassemble the old one. One thing that I did get right in the old one was the built-in noise filter here, and then also output plugs for the different drivers. So this were functioning as the power output for those. So I think I might actually take these ones out and put them into the new enclosure instead, because now the old enclosure here is pretty ruined by the big holes for the CEE plugs that were made in the chassis plates here. So there's not much reuse in this anyway. Now the old unit was built up in 3 different parts, so it had 3 timers, one for 230 volt AC, one for 16 amp and one for 32 amp. But as you can see, I actually never finished this. There was not wires in the large contactors or the smaller ones, and there were only these soft start power resistors for the 16 amp service as well. So I'm going to rebuild it with the largest contactors and only use those. Then along with the 4K 7 ohm resistors, 50 watt power resistors, and I can easily use these for almost any size load, because they're only going to take the soft start on charging up capacitors or a iron core transformer starting up, just the inrush current. So they're never going to see a full 50 watt dissipation in long-term use. Maybe a peak that's a bit higher, but yeah, nothing too serious. So we're also going to use the power supply. Away goes 4 contactors, and away goes 2 timers. So I'm only going to use one of these Omron timers here. It's going to be a on delay timer, and then we are of course going to use some of these switches. So a bit more disassembling of all this, and we can start making out which parts goes where. This is turning out a bit more unusual project, because now I have all my wire harness, I have all the parts I need, I have almost everything, even the cutouts I have to make in the new plates I can just draw after the old ones. So it's an actually relatively easy to approach project. Yeah, so I guess all there is now is to make a test layout on the new chassis and see how everything would fit in. But I have pretty much a good height in it compared to the old unit. So I think I'll just of course have all my DIN rail mounted components in the bottom, and then plaster it with in and output plugs on the sides, and that's about it. I think except that the large switch, which is used to switch between 16 amp or 32 amp service input, is going on the top instead. But yeah, we will see. The table has been cleaned, a empty coconut shell for all the screws, nice local fruit from Denmark. We grow so many coconuts in Denmark, love the cold climate up here in the north. So let's get the new chassis top plate. This is where I thought about mounting this large selector switch, but I think maybe it would go in between the 2 plugs instead. So let's get that to the side, and let's look at the new chassis here. Alright, so as you can see, we have a good height in this. So even putting this inside here, it could be, yeah, 1.5 contact that could be underneath it still, so that's quite good. So I think I would actually put it here at the side and then have 1 input plug on each side, so you can switch between those. Would also make the wiring a bit shorter and easier, and also actually come out on the same side where the plugs is. Of course I have to do this, else it makes no sense. So we have that, putting in there. So it's just about getting the DIN rail components. Yeah, they can practically sit anywhere, it seems. And of course we have the safety relay, but that's just another normal unit here. All the output plugs would then be mounted on the opposite plate over here. Preferably the large ones furthest down, just to not have any heavy cables pull down the plate over here, and then all the smaller 230 volt AC up in the top. So yeah, I guess there is not much else to do than get the DIN rail. That's also fit. Yeah, that's just perfect. So now it's just getting it all together. The first plate is done, which is the input panel. We have the 32 amp input, 16 amp input, switching between them, a key switch in order to actually turn it on, the reset button, and the red lamp for signaling that it's either in countdown mode or turning off, it's ready and dangerous. And it has, of course, all the wires ready here to go into the box. And the box itself, not so much new here. Everything on a DIN rail, along with some earth connections, earth terminals here. So yeah, let's get the other plate down and we can start wiring up the box itself. So far so good. Both panels have been made. The front panel with inputs, bypass switch, key switch, control voltage input. This was not shown in my initial video or the initial introduction to this. We have the reset button and get ready button. On the other side we have all the different outputs. We have the 32 16 amp and some 230 volt AC distributed over the three phases. And then I have the instrument or control driver output, which comes from this filtered input, which will also power the power supply here. So on the back side there's now an Emi filter, which is not a bad thing to have around a Tesla coil for the control parts. And on the other side here it's just a bunch of wires. So yeah, that is going to be mounted in a way so that I can open these two panels up just have them laying down like this. That's the reason for the length of wire here. Same goes over here on the other side. That it should be possible for the panel to open up like this and then get everything mounted in here. Then it's completely open to service and easy to get an overview, and it can all just fold up again and get mounted, something like this. So it's a little crowded in there. So yeah, all there's left now is just get this connected. The show controller has been connected to the safety box, so let's go through the startup procedure. Now I'm running on battery, so turning on battery power. We want to turn on the safety, or at least we want to turn on the power to the safety box. Now I have a fan installed there. Now we can see there is power on the power supply and safety relay. We can switch on safety and listen for the small click. That is the click of the two relays for the two monitor channels on the safety relay. So we can try to turn it on. It won't happen as long as the safety circuit is not reset. We can't reset if this is turned on, so we have to turn that off, then reset. Now on is safety relay OK. Light in the red button needs a new marking, but that would be that on is in a not ready but still dangerous state. And once it does its countdown, it will go into a state where it turns off the red light. And turned off red light, lighting blue light means full power is on, and be cautious. So right now it's set for just 5 seconds, just for the sake of the video. There it goes. Now soft start sequence is over. If I press the emergency button here, we will cut out the safety relay. Open it up again here, nothing happens, it's still turned on, we can't reset, no power on the main relays. We have to turn it off, can't do it again, turn it off, reset, restart timing sequence, and it turns on again. So the soft start sequence and safety relays all work in this manner, and if I take any kind of part of this out, like the fiber optic, well, it will cut out. Have to restart the sequence again. So overall, pretty safe setup. If anything fails, it will shut off. That is the prime purpose of using a safety relay, and something everybody really should use in their main circuits for something as high powered as a large Tesla coil setup like this. There is one thing I did not try, and that is can this be operated from a interrupter. So let's just try to do the reset and soft start, and it's turned on. The fiber cable comes from the safety output. Let's take that out and put it into a interrupter running at very low frequency here, and of course that's not suitable for a reset. So let's turn up the BPS. Maximum BPS is around 500 Hertz, I think, and we can't reset. And you can't really see a difference on 500 Hertz or the 600 needed, but you cannot use a interrupter in order to bypass the safety. So if we put it back up here in the safety output, we can reset. This really does conclude the whole 2-year project of building the 6-coil show controller. And now with the soft start safety box, this really sets this off as a complete show setup for 6 Tesla coils all at once, playing MIDI, playing normal interrupter, full safety features, really a, I won't say bulletproof setup, but at least a very safe setup where I use industrial grade components and safety rated components in order to keep this mains part as good as possible, and in case of any component failure we should see complete power off on the dangerous parts. So I really hope you enjoyed this build. I hope it inspired you to work in a safer way with electronics and also design your circuits in a safe way. Always design with safety and fail to safe state in failure modes. So until next time, see ya.